In this video, we're going to look at an overview of some of the tests that you're going to perform on your DNA sample from last week using UV spectrophotometry. So you're very familiar already with the principles of spectrophotometry. All based on Beer-Lambert's law of A equals ECL, we can set the wavelength which is going to pass light through a sample that we have loaded into a cuvette, and the machine is going to record the absorbance and provide us with that value. Beware when you go to use a cuvette, depending on if you have loads of a sample or very little of a sample, you may choose a large chamber cuvette or one that has a smaller chamber. But in both cases, the wavelength that you set and the light that gets passed through the sample travels through 1 centimeter. So you can use either or. If you have very little sample, we also have a nanodrop machine in the department, which may be suitable for your needs. So with the machine, we can set the wavelength, the nanometers. We can control this, and whenever you use different wavelengths, you have to first zero the machine with a diluent, such as in some cases it may be water. With nucleic acids, we measure at 260 nanometers, and the OD260 is often the optical density 260 is a phrase you'll see. So 260, as you'll see here, it doesn't sit in the visible spectrum. It actually sits outside of this in the ultraviolet or UV spectrum, and for this we need to use quartz cuvettes. So we have a specific type of cuvette you have to consider using when you go to test in a standard spectrophotometer here. Sometimes now there are companies that are bringing out certain plastic versions of cuvettes that can work in the UV spectrum, so be aware of what cuvettes you actually take when you're measuring your samples. So essentially, what are we trying to do with our DNA? Well, one, we'd like to examine the concentration in nanograms per microliter of the genomic DNA, and we can do that with the A260s. We want to identify the level of purity in the sample. We can do that using the A260 and a 280 ratio. And we'd like to examine the integrity of the DNA sample. So is it degraded, or does it still have good integrity? And we can't do that with spectrophotometry, so we'll use a different technique which we'll be looking at next week. So we're going to keep our sample for that. But the top two we can analyze using particular equations. So just to look at those for a minute. A260 is your absorbance at 260 nanometers of your sample, multiplied by 50, multiplied by dilution factor. That can tell us the concentration in nanograms per microliter. So A260, absorbance at 260. The 50 is coming from the fact that at 260 nanometers, if you have double-stranded DNA with 1 centimeter path length in the cuvette at a concentration of 50 micrograms per mil or nanograms per microliter, you get 1.0 absorbance. So we can use that coefficient to that value here. And the dilution factor, just be aware that if you do a 1 in 50 dilution, a dilution factor would be 50 in that case. 260-280 ratio gives you an idea of the purity of your sample. So we measure the absorbance at 260, we zero the machine, measure at 280, then we read our sample at 280, and that gives us an idea of the amount of protein in the sample, or protein, in our case, contamination. 280 measures the double ring structures in the amino acids, the aromatic amino acids, tryptophan and tyrosine. So we get an indication then, if we get this ratio between the two, of the sample's purity. So the closer to 1.8 for DNA, the purer your DNA is. If you're looking at RNA, you'd hope to be nearer to 2. So I hope that gives you an overview of how we can use UV spectrophotometry, and how in this session you'll be able to determine the concentration, as you see here, and also a level of purity of your sample.